Matveev. The topic is cost-efficient data privacy protection and multi-cloud storage. I'm from London, Russian Federation. So first of all, thank you for giving opportunity to present my work. It's my first presentation at fully scientific conference. Let's start with the first motivations of the work. Basically, there is a big growth in the cloud storage usage. Happens same time with the overall growth of the data. I think some of previous presenter highlighted that we generating more and more data. But not only that, because we have more data, the data end up more and more data end up in the cloud storage. There are also, I think, two underlying reasons for that. First of all, is the high cost of storage data into on-premises, because you have to build such storage systems. And second is the trend that data have to be accessed almost instantly on demand, and sometimes on the foot when you travel or go somewhere. So data have to be mobile. So as a result, users start to use more and more cloud storage as a way to mitigate such issues. But in other hand, we have disadvantages of the security of the using cloud storages as a security issues. First of all, is access control. We don't know who we're not sure even who is actually able to access the data. Only thing we know that after we send the data into clouds, in the cloud storage, the cloud provider is now able to access the data because we actually give this data to it. So there is might be also unintentional cases of breaking that data access. By the way, I forgot to mention that despite that cloud storage providers offers typically a privacy statements that they ensures privacy policy, that they ensure that no one is accessing your data. But there was a few incidents already. First is unintentional data leaks. There was several incidents with Dropbox, several incidents with Google Drive, very big one companies. And second is a business and government espionage. There, for example, report of Edward Snowden already show that it's happened on big masses when the USA government actually does spying on their not only their citizens using big tech companies like Microsoft, Google, etc. So issues are real. Incidents is confirming that, and this topic is not is not first discussed into the scientific world. So when I looked at made some research of the related work, I found classical, I think, three sets of the studies, which can be described as state of art and proposed solution. Proposed solutions divided into two, can be combined into different ways: more business oriented, or directly or more specified for individual usage or small business usage. State of art typically just describes what threats are, what the history is, and maybe sometimes can contain some solutions. From the state of art, I built a more complex picture of that model, which I used into my work, which we later will see into this presentation. And next, let's have a look over proposed solution. Business-oriented solution. Now, new way of business-oriented solution may mainly start to look into multi-cloud approach. Instead of just put as here somewhere X into one basket, they into one box. Currently, the approaches proposes solutions proposes using multiple clouds to spread data across them, and some of them also uses it to provide data redundancy, like happens with the RAID 5, RAID 6, and the storage controllers. Some solutions also focusing on providing some proxies, which either enforce insecurity or re-encrypting the data, such like in re-encryption proxies, to allow shared or common usage of the file with a group of users, dynamic list of the users. So so this is a basically what's I put it into category of business-oriented solutions. And there is only few issues. First, the business solutions first does not directly talk or maybe provides some information about key distribution, but it typically involves that we users somehow with the physical channels of communication exchange the keys, or we using some maybe corporate server with the keys or something like that. Some solutions with this. In example of also as an example, we can look at intermediate proxy servers, where, for example, use the re-encryption proxy, where when one user wants to share, no, even not one user, when users want with the users who eligible to access to the file want to access to such file, requiring this file, re-encryption proxy server take this file from cloud storage, decrypt it with its own encryption key, and encrypt it with user's key in order to provide user ability to read this file. So as a result, we have an encryption key stored inside the server, but because this server contains sensitive information, we cannot trust to locate the server into the public, into the cloud. So the server must be located into premises of the user. But those approaches increasing the cost of the solution, cost and complexity. Data split across clouds requiring paying for all the clouds which involved in the solution, because if you have much data through and going through the threshold of how much you can use for free, you have to pay. Hosting solutions, like I mentioned with the re-encryption proxies, it's still not suitable for individual users. You have to deploy it, you have to somewhere locate it physically, you have to build access for it, pay for electricity, etc. So by that, that's why I put it here, and that's why I think that's not suitable for the users. But meanwhile, I found few solutions which offer security for individuals or small business users. Those solutions mainly password-based because it's for user it's very like a regular way how he or she get used to interact with the security. Users typically have very poor interaction with the keys. They either cannot buy some hardware to manage a proper managed keys, or cannot configure it because it's too complex for them. So as a result, most of the solutions still be password based if they want to be reachable everywhere. One of the solutions also proposing data slicing to increase security, to put data into different clouds, and which literally almost make it impossible to perform brute force attack on the data. And both solutions proposed to, which I found, proposed to store small parts of data or key data into end user devices. But this creates some potential issues. First, data availability. If a user lost access or for example, lost forever access for the device is broken, and for example, hardware is no longer operating with all data. User might be not being able to access the data, might be no longer access to the data. So other thing, if user, for example, go to travel and have no physical access at the time when user wants to access the data, access these physical devices, his or her devices. So at that time, user can also cannot get the data which he or she needed at the time when it actually needs. So those solutions are not good at data availability. The other thing that most of the password-based solution easy to crack, just with a combine all necessary data. If data stored into the cloud, if solution fully store all data in the cloud, it's easy to crack, despite the password basically in theory provides enough strength to be not just be brute forced, but actually users do not use complex passwords. And in one study I found that reference to another one study which directly shows that it actually a problem and became not a technical problem, it became a behavioral problem of the user. So as a result, the solutions cannot just rely on the passwords. It's not safe to do so because users are choosing using the typical words which can be found into password libraries and can be used very easy to. They can be used for very easy to brute force and crack password. The data slicing, as I said earlier, here to increasing the cost of the solution. If you store data in different clouds, you have to pay for all the clouds which you use, which for individual users also might be not a good case if they don't want to increase the cost. of the solution. So the also interesting thing that is a proportion of the works. So the only 2 studies from the whole list of which I able to find is aiming to individual users directly. Listed here. I mainly looked at I think included into my work about 16 or 18 works. From their solutions about security is about 8-10 works, and only 2 of them only talking about the providing data privacy for end users, individual users, not the business solutions, which I drew before. So as a result, I came up with an idea about providing a new scheme which will increase data privacy, but which also will take into account data availability. That the data will be available at any time, despite not how do I say, in comparison with previous solutions. And forget also here one work. Second one is not aiming to instant access data at every time. It's aiming to provide a way of recovery data when mobile device is lost, and basically it's used for saving ID cards like passport, bank cards, etc. Such kind of security information. And from this perspective, this work is, I think, good enough, but for the regular data is not suitable always. So we have to take into account data availability, which means that if user lost device, and for example, users traveled somewhere and had only the device at that time, which he or she lost, he or she still have to still be able to access the data located into the cloud, and by that scheme have to locate all data inside the cloud, which it relies on. And from other perspective, the proposed scheme does not need to increase, does not need to have to, does not increase the cost of the owning solution in terms of money. So if users want to pay to one cloud, users will pay only to the one cloud. So that's is main objective for the scheme. Let's now see what scheme is. First of all, it's looked similar as a password-based security, which typically used for the users. But it's not only relied on the password. It actually became a multi-layered security, which boosted with a multi-cloud approach. But instead of splitting data across the clouds to make harder for intruder to get all combine all data, in my scheme, I do split key information across different clouds. Meanwhile, the protected data are located only in one main cloud. Also, scheme offers ability to make multi-layered encryption, and the scheme itself relies on existing security algorithms like encryption algorithms and etc. Scheme only provides an order of the usage. That is a short description of it. So Let's see first part of it. Here we can see how payloads are, how the content, how the payload is secured. For the securing users' data, we just perform a multi-layered encryption with the functions E and getting the ciphered secured payload, which can be stored into main cloud, the whole file. So encryption happens with a case key1, key2, maybe even more, the case key, which is extracted from the keyed gamma sequence, GK. Gamma sequences here is just a random bunch of bytes, random generated. Basically, I think that's it. I think you can see from here that now focus of the securing shifting from the payload to the securing the gamma sequences. So we have to secure gamma sequences, key gamma sequences, and for to do so, we have second part of the scheme, which offers this. Also, I forget to mention that we have keyed gamma sequences. The count of the key gamma sequence is equal to amount of layers of the encryption. So if you have 2 layers of encryptions, we have 2 key gamma sequences. So next, to secure all key gamma sequences, I introducing transformation gamma sequences. Transformation gamma sequence tool also just randomly generated, and their amount equal to amount of the clouds. So if you're using like 3 clouds, there will be 3 transformation gamma sequences. Sorry. Next, what we do to protect key gamma sequences is to blend them with the transformation gamma sequences. Blend function shall be reversible. So from the result we can, and having transformation gamma sequences, we shall be able to recover inputs of the function. So we do blend sequentially key gamma sequences with each transformation gamma sequences. As a result, we have protected key gamma sequences. Next step is to encrypt transformation gamma sequences and protected key gamma sequence with encryption KR and get ciphered key gamma sequences, and then locate them across different clouds. The encryption key for the gamma sequences is derived from the password which user provide to the program which actually perform the encryption. The password itself also combined with the salt, going through some functions which generating key, and then as a result, we're getting key for encryption. In current approach, also I proposing to use different salts for different gamma sequences that increases amounts that creates literally different key scheme for each gamma key, and also increases amount iterations for the intruder to when he or she needs to crack this scheme. Increases complexity. So now implementation aspects and considerations in the scheme. First of all, it's usage of the streaming mode for ciphers. for streaming symmetric algorithms. So functions R here and E here is symmetric one. By the way, about decryption. Decryption is basically just reverting the old stuff. So first of all, get basis on the key, we're recovering gamma sequences, protected key and transformation gamma sequences, then unblend protected key gamma sequence, getting key gamma sequence, and then undo layered encryption. So and decryption happens just in the reversion of all operations. So for the encryptions, we're using symmetric ciphers, and better to use streaming mode, because I think you all know that block mode is vulnerable and provides opportunity to get information about the data which is encrypted in it. At least CBC mode, but this can be considered at the time of implementation, which mode actually to use. Function H can be the function which transforms the password with the salt, can be just any hash function, or maybe password-based key-derivation function too. Path-based key-derivation function 2 is designed to slow down the process of the generation key, especially designed for the do so. And here does not influence significantly. It's used here because this part happens only once when we initialize the scheme, when we first time creating the gamma sequences and secure them into the cloud. And second, when we're starting decryption session, but after we getting key gamma sequences, we can cache them into memory of the process, memory of the program, and we no longer need to require to perform again this for the next file which we want to decrypt. So as a result, any operations which we have here, we can significantly increase in complexity, and it won't be resultant in a big loss of computational cost of when users start to work with the program, with the implementation of the scheme. So that's why this functions here. As function B, we can use here just simple XOR, exclusive OR. The gamma sequences both are just a random generated sequence of bytes, so there's no ability for intruder to guess or somehow exploit XOR. There's no pattern, so XOR shall provide enough encryption. As function X, which extracts key from the key at gamma sequence, we can use function slice. Slice is just taking first bytes, but also can be considered any another function which can get specific size from the input byte array. Even can be discussed using again password-based key-derivation function to here. Next proposal is MAC discarding. Streaming modes of symmetric ciphers typically producing a message account. Message, forgot how does it in English. Message authentication code, sorry. Method authentication code into the payloads to check that decrypted payload is correct. But if we locate MAC into, for example, gamma sequences, it allows intruder to perform a brute force attack, password brute force attack on gamma sequences separately. It provides opportunity to check the KM that is valid. But if we remove here MAC levels, it's MAC signs, the intruder will be unable to verify that gamma sequences is correctly decrypted because they are random, and he or she need to decrypt all the collect and decrypt all the gamma sequences. And next, also MAC discarding can be looked at bottom level of multilayered encryption for the same purposes, to do not allow intruder to guess and check that this case is valid, to literally make possible for the intruder any key be valid key. So intruder have to, as a result, have to collect all gamma sequences and then only try to extract this keys. And after performing decryption of this layer, he or she will be able to verify that key is valid. So also gamma key caching. I also before told that it can be happen in memory to reduce some reduce amount of necessary calculations of part 2. Also, gamma key caching can be stored somewhere permanently on the computer. At least they secured by password, but also they can be secured in even different way on devices. Device can support, for example, biometrical sensor, and we can use biometrical sensor to secure data. And maybe a backup of the gamma key sequences to be sure that they, if cloud provider is going unoperated, delete file, delete user, drop user from the platform, the user will be able to access the data. The next proposal is about gamma key location order. Gamma key location order for the locating, it's regarding locating encrypted, protected, encrypted keyed gamma sequences. The main view is to take priority, to give priority to non-primary, non-main cloud, to store them. First, store on non-main cloud, and then at the latest, if there are enough layers of encryption, store the latest layer into the main one cloud. And randomization of base index of the gamma sequence to prevent possible attacks, for example, on encrypted data, like behaving of the homomorphic encryption, when intruder could theoretically, possibly, if it will discover it with encryption, perform XOR operation onto encrypted files. It shall be not possible, but if it will be, so intruder will have to be, it will be not, but by this scheme, it will be by moving the first byte of the gamma sequence to random position. It will be literally impossible to guess, to perform such operation, because bytes no longer match into files of the gamma sequences. They're different in different positions. Here is proposed way how we can do this. It's all proposals and can be not implemented in actual implementation. So next is that model. We have such that model. We'll try to go shortly about it. First, password brute force. It's possible, but I do think it's unlikely. First, before we go with the analysis of threat model and complexity, I want to say that the security of end user device is out of scope for the current study, because first, we consider that that the open data in open form is stored in the device, so there is no purpose to attack our scheme, because we can intruder can directly download the data from the end user device. Second, there is other solutions which can improve the such security on end user devices. So we consider that end user device is safe and don't touch it. So from this perspective, password brute force is possible, but it's very unlikely, because intruder, if have no access to end user device, have to collect somehow all gamma sequences from all clouds which users mentioned, and the user can safely and easily set up 2FA authentication, and it will be very hard to do. So inconsistent use of encryption. It's possible. It's very likely scenario if, but it's mainly based on implementation. Like I said, for example, blockchain block modes into symmetric ciphers can be not good can provide vulnerabilities. Catastrophic hardware failures. Again, there's few scenarios. First, incidents inside data cloud providers, but they have good hardware redundancy. They had claimed so in public documents. Other thing is a network failure or DDoS. In this case, the likeliness or unlikeliness of such event is same as with scheme and as without the scheme. So scheme does not change anything in this question. And the latest is a device loss of the user, or of catastrophic failure of end user device. In this scenario, scheme allows user to get a new device and safely access data from the new device. Main in the middle attack, data leakage, side channel attack, and data disclosure can be basically, I think, and even malware can be grouped into one thing, in which intruder somehow gets access to some portion of the data. But for the intruder, it will be hard to get to unprotected to clear data, because intruder have to perform attacks on different on all clouds. To intruder have to collect data from all clouds which we use, and it is very hard to attack all the clouds in one time. But after the incident had happened, for example, we knew that there was a data leakage from the cloud, we can provide a mitigation measure. It's to re-encrypt all data with a new case or regenerate case to enforce the security of the recover the security of the scheme. But in one time, it's very unlikely to happen into multiple clouds, because they have a different infrastructure, different security, different vulnerabilities, and that if you're using 3 clouds, that intruder have discovered at one time 3 different vulnerabilities and been able to go inside 3 different networks at the same time. It's hard to imagine. And or there happened 3 different leakages at the same time. malware on the end user device is also not considered. As I said earlier, there is different tools to mitigate such threats. So next and last, almost accessing scheme complexity. For this, we're assuming that all spec proposals for implementation are implemented. Single password key iteration is a pair of one key derivation and decryption operation, and single test iteration is a decryption operation. For the password brute force, we calculate an amount of iterations, password test iterations with the list L. Basic, we compare. I compare my scheme with a basic password scheme where just password and one layer of encryption used to encrypt the data. So for the basic password protection, we have just L iterations with the length of list. So as long there is, as long as so much iterations we have to take to check the passwords. But proposed design offers 2 times n plus t more iterations than basic protection. With n equal to n, its amount of the layers, t is amount of the clouds, it's equal to 3. It will be 7 times more than a classic approach, the password-based protection. In case if we introduce two-layered encryption for the gamma sequences, as I told earlier, it's not problematic to harness this part, and we'll introduce two-layered encryption for the gamma sequences. It will be 12 times more iterations to test password. So a single one password. And we need to keep in mind that password brute force considered as a very unlikely scenario because intruder have to collect all gamma sequences in order to do password brute force. They are distributed into separate clouds. So the another one way is encryption attack on the encryption key. So the proposed scheme offers again W permutation, no, n permutation of W. I think I properly announce this formula, which almost equal to growth exponentially. It's almost exponential growth of the key test iterations in comparison with the basic password protection. So it's also very hard and almost impossible, makes more impossible to breach security. But we need to admit that the I need to admit, sorry, that amount of layers and here cannot be easily increased without losing the performance because it's multilayered encryption of the payload. And the limitations of the scheme is present here. It's required to offer such security at least 2 clouds. With a single cloud, it's just a password-based security, nothing more. Scheme itself does not offer resilience against a loss of the one cloud. If one cloud is going offline, we no longer be able to access the data. But as implementation, it was stated in the implementation proposals, we can cache data, cache keys, and from the keys perspective, we can still be able to access the data. In terms of the main cloud, it's an issue which has to be discussed, but because of the main objective, it cannot be resolved without broke the main objective here. We need to do data redundancy otherwise. The big issue became a file search because the data encrypted. It's became hard to search files. And current scheme is not taking in consideration sharing data with any other users, which we might want to share a file with. Yeah, and I think that's all. Thank you for your attention. And if you have any questions,